Hi, Chris Kuzmal here, BC Calculus, the chain rule. The chain rule is defined as such. If we have a function of a function, a composition, in other words, f of g of x, the derivative of that is the derivative of g of x times the derivative of f with respect to g of x, or we just write f prime of g of x. And as it says here, this is really important. You cannot do derivatives without the chain rule in general. And you can do virtually every derivative when you can take the derivative of virtually any function if you have the chain rule at your disposal. And the base level definitions as well. So let's use the chain rule when we don't need it. Okay. Let's suppose that f of x equals x and g of x is x squared. So what is f of g of x? One of the keys here in term to understand and apply the chain rule successfully is to recognize what function composition is. Personally, I would sort of guess that f of g of x is x cubed. That's wrong. Okay. Composition is like substitution, and so we're going to replace x with the composed function. In other words, we're going to replace x with whatever g of x is. Well, f of x is x, which means f of g of x is g of x. We replaced x with g of x. All right, that's just a thing to keep in mind. Let's continue to use the chain rule when we don't need it. Now f of x is x squared. G of x is also x squared, which if we compose it now, our intuition where we had x squared and x, we thought we would get x cubed, but we got x squared. Now we have x squared and x squared, you would think, oh, maybe we would get x cubed now or something, but no, you're going to get x to the fourth power now because you're going to replace x with g of x in f of x, and that's going to be g of x squared. Well, g of x is x squared, so x squared squared is x to the fourth power. Okay. Interesting little side thing is how could we do a composition that came up with x cubed? Don't know off the top of my head, but it's an interesting idea. So the chain rule, the derivative of f of g of x is f prime of g of x times g prime of x, which we've memorized before. Well, so f prime of g of x is just 2g of x. Remember that x squared, we're just going to take the 2 down, 2 times g of x. G of x is being treated like a variable. And then we multiply by the derivative of g of x. Derivative of x squared is 2x. That's 2x times 2g of x. All right. And we bring our 2's together. We pull our 4 to the other side, 4x times g of x. Remember, g of x is x squared, which makes the whole thing 4x cubed. And that matches the power rule, by the way. So x to the fourth power, you take the 4 down, you subtract 1 from the 4, 4x cubed. Well, that's exactly the same thing. Lovely. So now we didn't need the chain rule for the prior examples, but now we do need the chain rule. If f of x is equal to the sine of x, okay, and g of x is equal to x squared, then f of g of x is the sine of x squared. Now we're going to take the derivative of the sine, which is, no, there's the definition of the chain rule again. The derivative of the sine is cosine, and the derivative of x squared is 2x, which we multiply by the cosine of the function that is composed. And so we get 2x cosine x squared or cosine x squared times 2x, whichever way. Usually it's probably more clear to put the 2x in front because you don't accidentally confuse whether or not the 2x is inside the argument of the cosine function. Okay, so that's all. That's a couple of unnecessary uses of the chain rule and one necessary use of the chain rule. The chain rule needs to be something that's very automatic for you to use. It's, as I've said, essential. It is kind of intuitive, I think, in terms of how to apply the procedure. You can kind of, I think it's easy to think of the fact that I'm taking the derivative of a function of a thing, and then I'm taking the derivative of the thing. I'm multiplying that by the first derivative. That's a process that I can easily memorize and have a mnemonic for, but we are at this point in time lacking a really good intuitive explanation of the chain rule. Sorry about that.